Well, welcome everyone. I hope you're all having a very good day so far. Thanks for joining me. Today we're going to talk about the GeoWeb Earth Retention System, with a focus more on the design software, the free design software that we offer called GeoWeb MSE. A little about myself: I've been the engineer at Presto for about 18 years now. Before joining Presto, I spent 18 years as an engineering consultant, working on a variety of different civil geotechnical projects. I'm an active member of a bunch of different committees, relaunch of railroads, ASTM 18 and 35, which is geosynthetics, and also part of the ISO committee 221 on geosynthetics. So today I'm going to try to share my thoughts on both perspectives, drawing on my 18 years as a consultant and 18 years as a manufacturer at Presto. So we are going to be talking about retaining walls today. So the system works for both types of retaining walls, whether it's a gravity wall or a reinforced wall. This software also works for reinforced slopes. So we're going to do a real quick review of wall types, discuss all the benefits from the GeoWeb system. Then we're going to get into the beef of the presentation, which is really talking about the MSE software. So I hope at the end of the presentation today you understand that software. Like I said, that software is free. If you're interested in a copy, please reach out to me or to Presto, and we can get you a copy of that. So a little bit of history, Presto worked with the Army Corps of Engineers back in the late 1970s to develop the GeoCell technology, and we really have been the leader in innovation ever since. So we do offer more than a product. We'll work closely with you from the initial concept phase right through construction. We do have a worldwide distribution network, experience really not only in our GeoCells, but also geosynthetics as well. I really believe that we have the most knowledgeable distribution network out there, so they could support you not only in the GeoWeb, but also any type of geosynthetics such as grids, fabrics, erosion control blankets, TRMs. So we'll definitely help you all the way through, and we will not stop once our product leaves the door. We will be on site with construction. So we operate in 4 main product areas using GeoWeb. So we can use for load support, slopes, channels, and what we're going to talk about today is those retaining walls. So we also offer porous pavements, both vegetated and aggregate solutions, and also lightweight construction mats, which is called GeoTerra. So let's get started with the GeoWeb system itself. The system consists of 2 main attributes. The first is the cell diameter, the actual cell size. The cells come in 3 nominal diameters, 8.5, 10.5, and 18 inches. The cell wall heights are 3, 4, 6, 8, and 12 inches. For walls, we pretty much have standardized 6 and 8 inch wall panels. So, and the actual size and the height will depend on the site-specific project details and your conditions. So, and you'll hear me say this multiple times through the presentation, we do offer free project evaluations, which will include like a written summary, calculations, drawings, and specifications. Once again, that'll be no charge as part of our service. And I highly recommend for any GeoCell project when you're working with us, do not use any standard tables or graphs. Every project is different, has different site conditions, especially if you're looking at walls. Walls are really important when you're looking at global stability. So it really is dependent on site conditions. So please reach out to us and we'll give you that free evaluation or assistance if you decide to download the GeoWeb MSE software. So the ultrasonically welded seam, that's where all the connecting points is really important to the function of a GeoCell. The stronger the seam, the better the performance. And that's period. So the stronger the seam, you're going to get better performance. Materials constructed out of 100% virgin HDP that provides the strongest wall strength that you can get, but also maintains a semi-rigid properties, so somewhat flexible. Too stiff of a cell wall really does lead to overstressing of the seams and a potential for actually cell rupture. So the second attribute is the infill. We can fill with aggregate, low quality aggregates such as sandy aggregate mixtures, topsoil and vegetated, or even concrete. When we're talking about our walls, we're really always going to fill that front fascia with one of these 3 different types, topsoil and vegetated. If it's a more hard armor, we can fill with aggregate or concrete. Areas where, may be subjected to some erosive forces such as wind or water. So when you talk about the different fascias, This is just a front cell. For a wall, you're always going to have the back cell with some type of free draining material. So another important part of the component for the wall section is our after wall key. The after wall key is really used to connect the adjacent sections together through those material eye slots. It really does have that. It does have an integrated washer here, which prevents any type of loss of material from behind the wall. It has a nice handle here, which is easy to turn. We also added these frictional barbs here. They're hard to see, but on the back side of that after wall key, that does help the interlock and it's really do securing up the adjacent panels together. So we used to use metal staples, back in the day, and even looked at some zip ties. But over time, those metal staples are going to degrade, corrode. You can have separation of panels. Zip ties don't provide a secure connection. So just be aware when you're looking at different types of systems. GeoWeb, all of our accessories and our GeoWeb panels, our resins, everything is 100% made in the United States under strict quality, our QA/QC program. If you have any projects with the Build America, Buy America with the BABA Act or BABA, we can provide the documentation for that. So, once again, specifications are really important for any type of geosynthetic product. We have a very detailed specification. We stand behind it. We're constantly testing all of our parameters, whether it's an ASTM standard or an ISO standard. So as I mentioned, for the past 40 years, we've made our GeoWeb out of 100% virgin HDPE, no fillers, no unstable polymer alloys to make the product stiffer but less expensive. So we really want to make sure that we have a very good product that's going to work, basically through the life of your project. So a little bit on the walls. Let's get right into talking about the retaining walls, a little bit on the fundamentals. So we're talking about walls versus slopes. A wall really is anything with a batter less than 20 degrees. And we're talking batters, that is from the vertical. So anything less than about a 20-degree batter is considered a wall. Anything over that is considered a reinforced slope. So there really is no limit on how high we can go with a reinforced wall or reinforced slopes. So here you can see just when the wall is fully vegetated, it really does blend in nicely with its surroundings. Like I said, we can do different types of infill here, aggregate or concrete, depending on what type of erosive forces. So, steep slopes, very attractive solution for many reasons. One of the biggest benefits is the ability to, really build a solution that fits well with surroundings. Sometimes walls do look out of place. So here's a project that we did a while back to basically retain and prevent any failures to this road here above. So, reinforced slopes are also a very good option. So let's talk about gravity versus reinforced. Gravity walls, once again, no reinforcements. Rule of thumb, typically we don't follow FHWA, and our program is built for that. About 8 feet is generally the max height for some type of gravity walls. We do have different panel lengths, and when I say lengths, it's different cell lengths. We have 3 up to 7 panel cell lengths. When we're talking about gravity walls, I do want to mention though that once you go past 2 different types of cell panels, you say if you're having a 3 or 4 cell D panel, I would highly recommend looking at a reinforced wall because it does get hard out in the field when you're constructing with multiple panels. So just a little tidbit, I would highly recommend that. So like I said, we will help you with any type of these evaluations. Reinforced walls, like I said, there's no real to limit what we can do with a reinforced wall. Most of the walls that we do will have geogrid tiebacks. Rule of thumb, depending on surcharges and soil conditions, you're looking at about a 70% geogrid tieback length. And like I said, we'll work with you to determine that length. Usually it's going to be a 3-cell wall panel just because the GeoWeb really only is providing the fascia. On very tall walls, sometimes we'll have a 4-cell at the bottom up to a certain height, and then we transition to a 3-cell. But once again, we can offer that in different nominal diameters, our 30V and 40V cell size, which is our nominal diameters. And as I mentioned before, really a 6-inch or 8-inch cell depth. So like I said, really not reinforced walls. Unlike a gravity wall, they're not limited in height. But sometimes when you're looking at very steep walls, it may be very beneficial, and we can help you with this, is to look at multiple tiers or shorter height walls rather than just one single wall. This is because, like I said, with that 70% tieback rule of thumb, when you're looking at one very steep wall versus multiple tiers, that'll really cut back on that tieback length. So like I said, we can help you with that if you're looking at some type of design. So with that, we'll talk about the GEOB earth retention system. So, walls and slopes are very aesthetically pleasing. They really are environmentally friendly, due to the, really no maintenance, whether it's vegetation, aggregate or concrete. They really are, especially our vegetated walls, can capture stormwater runoff. So, using local grasses, some types of vegetation, really will help to ensure easy growth and a natural look. Our natural wall keys, as you can see here, most of our vegetated walls are going to be either tan fascia or a green fascia, and those keys really do help it blend in. I do recommend not using a black fascia if you're looking at doing a vegetated wall, because the black will attract heat, which will get rid of a lot of the moisture. So if you're looking to vegetate, I would highly recommend keeping either a green or a tan fascia. One other benefit of the GEOB system is, we're flexible. So unlike, some of the block walls or some of the other stiff MSE wall systems out there, we can really tolerate differential settlement. So building over soft soils, where differential settlement is a concern, is not a problem with our walls, unlike, say, a gabion or a modular block wall. So the reason differential settlement, may be different in every project, but, we can handle, inches upon differential settlement, especially when it's in saturated soils or, soils prone to differential settlement. And once again, we can work with you on looking at the types of settlements. So, if you're using the GEOB system, it can avoid expensive, time-consuming activities. A lot of our low support projects too are over soft soils. A lot of times we look into surcharging a site, which is often required for differential settlement. So walls, loads, the same thing. So we can really eliminate sometimes just any type of differential or site surcharging. So like I said, we'll work with you on that. This is interesting. This is the really big tsunami that happened over in Japan many years ago. We have hundreds and hundreds and hundreds of walls in any earthquake zone areas that are really issued a seismic, because, like I said, our walls are flexible and actually can move with earthquakes. So this is some of these slides that our Japanese friends shared with us. Like I said, we have hundreds and hundreds of walls over there dealing with, poor soils, differential settlement. Here you can just see a picture that shows here, this is a reinforced slope. You're looking before the earthquake, where you had the GEOB on a 45-degree reinforced slope with geogrid tiebacks. You have a concrete or reinforced concrete downshoots for the drainage from the parking lot. And you can see here after, after the tsunami and earthquakes went through, you had significant buckling of that concrete and displacement. The walls, since they're flexible, you can see actually moved and settled back into place, whereas the concrete had to be replaced and repaired. So durability, our GEOB, like I said, is 100% HDP, very, very inert to any type of, pH conditions, freeze thaw. It can really stand up to any kind of weather conditions. So we will provide the specifications that will back up our durability. And like I said, we're constantly testing the wall panels in accordance with the ASTM and ISO standards that are contained in our spec sheet. So the walls can be built in channels. We do a lot of walls, for instance, in the US, down in Florida, in Texas, any type of area along the Gulf Coast, especially when they're seeing a lot of hurricanes that come in. We have tens and tens of miles down in the Miami-Dade area where they're building this type of wall, filled with usually a topsoil and aggregate mixture. Basically it's limited space, maybe where you don't have a lot of easements or you're next to a roadway. So these are opportunities also that we can assist you with. It is a wall, but it's actually against a channel. So we have a lot of testing at the Colorado State Hydraulics Lab where we can show you the limits and how these walls will stand up to any kind of hydraulic conditions. So also challenging site conditions. Here you can see these are walls with They're basically a front fascia to a rock slope. We're basically preventing the rock. Here's a shale project in Ohio. We're preventing the shale from falling off into this highway, which was always a concern. And here's another project over in Japan that we recently constructed. So the geo is just really a fascia. So we can help you with those type of projects, more or less a gravity wall, because it is a stable system. But we do like to put some type of a reinforced zone behind it just to allow and make sure we maintain drainage. Very flexible system, as I mentioned a couple times now. The panels are, like I said, 100% HDPE. They can accommodate any type of construction around, say, culvert pipes, which is shown here in this slide, and also here pipe penetrations here for roadway conditions here. So basically, they're putting some metal tubes in to put some foundations down for some guardrails on a highway. So like I said here, you can just see the entry and all those pipe penetrations. So we have details for that, so we can help you with that also. The system is very flexible, as I mentioned. You can conform to any type of roadway here. I mean, this is a reinforced slope on a roadway. You can see we have some drainage structures on this slide. It's very flexible. This is an inside corner. We can also do outside corners by just over expanding and under expanding those GEO panels. So really easy to install in the field. And as I mentioned before, our distribution network, if someone from Presto isn't on site, someone from our distribution network will be on site to assist with the installation of the system. So now getting to the beef of the system, which I like to talk about a lot, is the MSC Wall software. It was really developed by Dr. Doug Lashinsky. Adama Engineering also was professor for many years out at the University of Delaware. It is an extension of a couple different software packages that he's been working on over the last 30 plus years with FHWA. So it is a true and tested program. It's very versatile. We can do a lot of different site conditions, and like I said before, we can look at vertical or gravity walls, reinforced walls, and also reinforced slopes. So I'm going to go through a couple examples, one for a gravity wall and one for a reinforced wall. Both of these can look at internal and external stability calcs, but I'm going to be showing you a lot of enter and outputs. So hopefully it doesn't get a little bit confusing. But like I said, this system, once you use it and download it, I have thousands and thousands of these copies out that engineers are using on a daily basis. And once you get used to the software, you can design a wall in a matter of 3 to 5 minutes. So it's a very, very quick system to use. So here's the software. It's completely free. All it is, we have annual updates on the software every December, because we typically do have some improvements to it. So it's very important to have your geotechnical conditions, whether it's a site investigation, borings, or whatever, when you're looking for any type of GeoWeb or any type of wall for that instance. So as I mentioned before, we can do a 6-inch or deep in GeoWeb panels. We have a library, I think up to maybe 12 or 13 now GeoGrids, different types of GeoGrids. Most of our walls, we are just only using a uniaxial GeoGrid because we really only need that strength in one direction. Here, like I said, it's going to give you options of picking that nominal cell size, whether it's a 30V, 10.5 nominal cell diameter, or a 40V, which is a 18.5-inch nominal cell diameter. And like I said, measure wall heights, usually 6 and 8 inches. So we do have training guides and also training videos that you can walk through for this program. Like I said, it's very easy to use. Most of the time, I would say a lot of times I'll spend 5 or 10 minutes with an engineer after they download the program. And after that, I never hear from them until they send it back to me and say, hey, Brian, I did a design. Can you take a look at it? And we'll review it, send it back to them, and recommend any changes. So I'll get into some, I guess, case studies. The first one we'll do is a gravity wall. This is basically a little wall out in California. This is your basic starting screen. You've got all the standard icons for opening, saving, and printing. To get started, you just click on that far left icon that says new. The first question is whether you're designing a gravity or a reinforced wall. In our case, like I said, we're working on a gravity wall. So we click on that and then we can go ahead and modify and enter our input. So this is the screen that will pop up, has all the information that you need to enter. It doesn't really matter, what order you really choose it in, as long as you get to all of them. So it's easiest to start at top. You choose what units you want. It defaults to English, but of course it does work in metric. And then the general information tab. You have to enter a lot of different information throughout this program. The time and the date automatically populates. The other big one is the designer's name. You have to have the designer's name, and you have to enter it into this box. If you don't get it, you'll get that error message. So make sure that you enter that in so you can move forward with the program. So now we're going to get into the meat, building up the model. Here's a new page opens up, and there are a lot of boxes that, like I said, have auto-populated. With the numbers, you can ignore those. They don't really mean anything. And you focus here, which is a diagram showing the variables represented in order to build up. In order to build that model up, we can use the help screen if we need to look at all the geometries and inputs. Here you just click. It gets you into the meat of the program. It gives you all the different types of measurements here. It's going to give you the front fascia. It's going to give you the back slope angle, the length, which is A. That's the distance between the face of the wall and the back slope. Then we have area B, which is length of the back slope, if applicable. So you basically just need, something from the edge to the road. Sometimes you'll have a toe slope below where the wall is installed, which is shown as that alpha here. May not always be in the wall. So you just click OK. Now we know all the variables, and we are ready to go forward with the program. And we do have to enter just the vertical height here, as you can see, is a 7-foot wall, and also an embedment depth. I would always recommend, if we can, at least a 1-foot embedment depth. Here's also your surcharge. You can see we always like to have some type of construction surcharge and how far away that surcharge may be from the slope. So if you need any help with that, please reach out and let me know. So hopefully, that's a lot of information, but like I said, it goes pretty quick as you enter them in. The first is the number of steps along the height of the wall. This allows you to control the number of times that the panel is used. So when I mentioned that, if you got a 3-cell, a 4-cell D program, so I would always recommend using a 2 or a 3. So here's another option. We don't usually employ it. It allows you to control the length of the very top layer. So I would just not check that box. Here's the section that allows you to choose the size and the depth of the panel. Remember, it comes in 6-inch and 8-inch high wall panels. Like I said, our 20, our 30V, which is our normal 10.5, and also our 40V. 20V, I wouldn't recommend looking at that. It's a lot of plastic, and geob is only a fascia, so you can pretty much stay away from that. Here, you're going to check the number of cells. I would recommend always checking 3, because once you run it, if it doesn't work with 3 cells, it'll automatically print out and give you, say, a 4-cell or a 5-cell wall option. So soils is our next spot. Like I said, it's better to get that from a geotech report. You can also assume, of course, some soil parameters, but just make sure you are a little bit conservative. Those soil properties, are the internal friction angle, cohesion, weight. There's 3 different areas that we look at. That is the reinforced, the retained, and the foundation soils. Here you can see the retained soil that's inside of the or the retained soil is behind the wall, and the foundation soil is underneath the wall. And you can enter different parameters for all of those different conditions. So once you're done, you hit OK. So here you can see this, basically it's showing the GEOM panel, shows the different type of areas, shows the infill going back into the GEOM panel. Here's the back slope, the reinforced or retained zone. Here's the front of the wall, so it shows any batter that you may have with your wall. Those are all the inputs that we looked at going into making of this gravity wall. So the next one is our design diameter tab. So you just click this simple screen pops up. You likely won't have to change, since these are all default values. So the next would be to click onto your seismic. Depending on where you are, you may not have a seismic parameter. All you gotta do is determine what the peak ground acceleration is for your area. Our case study is in Southern California here, so we are going to have a PGA that is a little high. So depending on where you are, you're looking at some different type of coefficients, and also depending on local regs, you may have to look at some vertical seismic coefficients that also may be addressed. This really is a function of the horizontal coefficient and needs to take gravity into account. So if you need any help with those, let us know. We can help you with any vertical. The next one is the GeoHub Design tab. So working your way down the list, you just click it. Like I said, this should look familiar. We looked at it before. At least I hope it does. So this is an easy way to get to this page. If you want to adjust or click something, you just click here. Still the most important part on this tab is the minimum number of cells per panel. So if your results are what you're looking for, this is one of the easiest way to just make changes. So once again, I always recommend starting with 3 cells, because when you go to run it, which I'll show you shortly, if it doesn't work, it'll show you basically an error where you need different cells. So you hit OK, and we'll move on to the general factors of safety. So this slide gives you some information. There's really not a lot of freedom here. You can't really change the factors without adjusting the face geometry. So note 1 states, that the wall faces greater than 70 degrees, use the factor of safety of 1.5. A wall less than that, or reinforced slope, basically you're looking at a factor of safety of 1.3. Our case study has a slope angle of 60 degrees, so it's going to be 1.3. And the only option you have here really is a reduction due to seismic. So if you check either box, the factor of safety is reduced to 1.1. As mentioned before, note 2, generally I like to leave these unchecked, even when you have a relatively high seismic coefficient. Really does give you an added safety, buffer during the analysis. So you basically, as always, as engineers, we always try to follow our best judgment, when doing these designs. So going to hop over to the left side of the menu now and look at the foundation effects. This is where you can ask the analysis to account for deep-seated failures. This is really helpful if you know your foundation cells are weak. If you have significant water movement through the soil, heavy surcharge loadings. The program does use Bishop's analysis and add this for deep-seated failures. You can choose, what factor of safety you're looking for, and in the end, decide if you want to run a global stability analysis. It is up to, once again, your best engineering decision whether you think you need this information. But it's always at least nice to know that you have the option to run a Bishop's analysis. This takes us to the last tab, which gives you the ability to create a CSI formatted specification. It's basically going to bring you to this tab. You just are going to specify the application, whether it's your earth, stack channel, whether you have geogrid reinforcements. And from that, it'll download a nice CSI specification in a Word format. Just make sure that you can save it as a Word document so you can go ahead and make any necessary changes. So this brings us to the last tab. Which is going to be, like I said, that CSS spec. So we're back on the main menu. You just click on that. And here you can see the model is basically shown on the right. We're ready to run the analysis. So you just click it. That's going to basically give you and show you what the output of your wall is. It'll also ask you to obtain your base length of your gravity system. Just always click OK here. So that's just another inside check. Just click OK. And you can also look at the layout buttons, which is the layout configuration, and we'll start that one first. A new screen pops up, which shows us the results. The geo panels are not shown in the model for full height of the wall plus the embedment. You can count how many cells are in each panel. As you can see that we have 3 steps worth of panels, starting with 6 cells at the base, moving to 4, and finally moving to 3 at the top. If you remember back to that design data, whether you select, number of steps, it's always going to print out what it gives for the different types. Like I said, I had mentioned too that I always like to have a minimum or a maximum here of 2 different types of panels, so it's not as hard to construct in the field. Okay. And once again, if it gets a multiple panels with heavy surcharges, say for instance, you might want to just go ahead and do a reinforced wall. So this is going to show you your outermost slip surfaces. Basically you can see here showing your Gillette sliding and your overturning. And you just click return. And then we can look here at the tabulated results. Here you can see, you can look at different types. You can look at, based on your details, the configuration of the cells, which is your elevation, the length, the number of cells. So here you can see we've selected that 30V. Here's every single row number in that wall. You just click. So that'll give you a nice summary of that. You can also look at your deep direct sliding and your deep seed results here. So once again, here you can see that we're looking at that factor of safety that we picked of 1.1 before. Here you can see the 1.4 or over. So it'll give you the status, which is okay. Here you can see it's calculating your required bearing capacity of 1,404 pounds per square foot. So, design analysis all done. We're back at that main screen. So you can see at the left point, we can actually do a printout of that. What that's going to print is a really nice report that you can actually summarize and put into your calculation. Here you can see it's going to give you all the titles. Once again, that designer name is really important. It's going to run that program. It's going to include the standard specification, depending on whether you're with the 30V or 40V cell size, and also whether you work with the different types of the depth. It's going to give you a full printout of that evaluation. Once again, it's going to show you the cross section of your wall. It's going to show you all your information here. It's going to show you your surcharges, how far that surcharge is from the back of the wall, and what that surcharge is. And here you see different types of walls. It's also going to give you and summarize all of your soils data. Here you can see here, summarize all the soils data, your seismic conditions. Here's your soils data. It's also going to look at your results of your sliding, overturning, and bearing capacity. And also it's going to give you a summary here just of the, the type of the wall, once again, that height, the number of panels actually needed for height. Here you can see the number of GEO rows containing 6 cells, 4 cells, and 3 cells. Like I said, I would highly recommend if it gets to that point, you're having issues with them, run the analysis, but try to limit it to 2. Or like I said, just go to a reinforced wall. So if you have any questions offline or when you're looking at a gravity wall, like I said, just reach out to me. So, that's it. It's pretty easy to design a gravity wall. I mean, they are functional and they are great walls. Like I said, they do have limitations with heavy surcharges. I'm sure we've all seen, gravity walls that over time, have slid. So, they don't have any back reinforcements. So a lot of times, like I said, if there's going to be high surcharges, I'd like to do a gravity wall or a reinforced wall versus a gravity. So with that, I'll do a reinforced wall. This is a project that we did a couple of years back up in northern Wisconsin. It's along a roadway. We had a lot of erosion into a creek bed. Had a lot of different soil conditions, a lot of freeze thaw. You can imagine northern Wisconsin. They came to us and we did an analysis for them. So once again, we start, by hitting that new in the up-hand left corner of the model. This time we make sure we have the reinforced soil selected, and then we can get to modifying that input. Basically, it's going to be the same format that you had before for gravity wall, but now we're just going to go down to the list. Once again, you're going to select your units, whether it's going to be English or metric. Once again, that general information tab, you got to make sure you have that the designer's name in there. This is a little bit different. You're going to have your slope geometry, your surcharge, in your geo design data. Here you can see that, once again, the same conditions as a gravity wall with your toe slopes, your back slopes, your surcharges. Here you can just see this is looking at a wall, very important, where it's getting installed with the stretcher frames and some different types of installation. Here you can see the interface eye, which is shown on the front of that wall. Once again, the area to that back slope or any kind of surcharge loading. You're going to have your width of your road, which again, that's B on that chart, which is going to be your distance to your surcharge loading, the width of the road. And here you go, you get back into that main input screen. Once again, you're going to input your height and your embedment depth. Like I said, I would highly recommend starting with 1 foot of embedment. You can always modify from there. 1 foot is usually more than adequate. If you have especially a flat front face, if you have some type of front faces on there, some slope angles, let us know, and we can work with you and provide the evaluation. So here you can see your crest length, which is that's going to be all the way from the front face of that wall going back to that surcharge loading, which is here. B, that's that horizontal crest length. That's going to be the length of that surcharge load. And here you can see that surcharge load is 250 PSF, and that's what we typically use for a standard as a construction surcharge load. There may be different loads such as buildings. There may be some different highways, some different structures that impose a surcharge load on that wall. But once again, we can work with you on that and help you with that. And we really do follow the FHWA guidelines. If you're familiar with that, that provides a lot of different information for, surcharge loading on MSE walls. So you hit the bottom at the right. Now here we're back to this is a different screen. We can actually choose, once again, the GW30 V6, different types. Once again, you select the number of cells and width. I once again would highly recommend just starting with 3. Since it's a reinforced wall, let's say under maybe 25, 30 feet or so, a 3 cell will be more than adequate for that, and depending on the surcharge. I always start with a 3 cell here. Here we go, we can enter all kinds of different geogrids. So there's different manufacturers in this program, like I said, 12 or 13 I mentioned before. What I would recommend doing is always selecting the lowest strength grid here. Like I said, just say if you're using a mirror grid here, I would select the 2XT here. And then if it shows you a failure mode, you can go back and just rerun it and just increasing the strength until you get the adequate geogrid. Here you can just some of the manufacturers, Tensar, Centene, Mirrorgrid, Esker, Nowe, McAfee, Greenfix. So there is a bunch of different geogrids that we can use here. Here you can just see the geogrid being installed on that. It does have the ultimate strength reinforcement, so that's going to include your factors of safety. So all of these we pretty much picked, and we developed the software with Adam Engineering. We took these right out of the manufacturer's specification books, and you can see whether that's reduced functions and factors of safety for durability, installation, and creep. So all those are included in the ultimate strength of reinforcement. Once again, just click on the lowest one. If you want to look at different ones, of course, you can click on a couple different ones, but I would just click on one and run the analysis and just go from there. But the next step would be the spacing between the geogrid layers. I've always start out with 2 feet. That pretty much is our standard. It's the most efficient for all of our, most MSE walls, not whether GeoWeb, but other different types of walls. So the height of the bottom layer, that's, I would just leave that blank. That doesn't really come into the equation a lot. And here, once again, there's that minimum length of the top layer. I wouldn't click on that. It just, because what you're going to do is, typically bring that up in a 3 cell wall and stop the wall at that point. So then you click OK. And now, once again, we're into that soils tab. So the same thing as with the gravity wall. You're going to go ahead and enter the cell infill soil. Your retained soil, that's behind the geoweb wall, and the foundation soil is underneath it. This infill soil, that is the not the front fascia cell, but that's the soil behind the front fascia, where you want that free draining material to prevent that pore pressure buildup. So here you can just see a photo of that, of the wall going in. Here you can see that front fascia is filled with the topsoil, just for a vegetative surface, and the reinforced drain soil that's going behind it. Here you can see compacted backfill in that reinforced zone, and the stream on the front, and any kind of front fascia here. So here are the design parameters. This is, just like the gravity wall. Like I said, if you haven't done any extensive testing, you probably won't have any changing in these parameters on this slide. The inclination wedge is, again, basically 20 degrees, and that's based on, FHWA and a lot of good assumptions. The direct sliding is another part. And here's your seismic parameters. Once again, same thing. Since this was in northern Wisconsin, we don't have any experience thankfully, with any type of earthquakes or things like that. So you just click on 0, hit OK, and that brings you back to your geodesign data. Once again, it's going to be a repeat of the gravity wall. Just give you a quicker way of installing it. Remember that choosing the number of panels here and changing our choice of geogrids, that's always an exception on that next step here in the GeoWeb design data. Just a quick way to access it. Here you go. Once again, general factors of safety, simple slide, not many options. The one that we can change is the factor of safety for shear strength of soil. I mean, it really does default to a factor of safety of 1. This has to do with note 1. Basically in the US, there are 2 main methods for reinforced soil wall design, AASHTO and FHWA. They do recommend different factors of safety. I like to use 1.3 or recommend it because it's a little more conservative, gives you a little bit more, robust and conservative design. And once again, your reductions for seismicity is also an option because there's no seismic concerns here. We just click OK, and back we go. So over on the left side is, again, the foundations effect tab. We click on that, and it gives us the same ability, once again, to run that Bishop's analysis that we saw with the gravity. We can use, what the depth is for the analysis. That's a 40-foot depth we're looking at. We can choose the factor of safety. And finally, the ability is to choose if we want to run that Bishop's analysis at all. Again, like I said, it's based on your specific needs and what type of analysis you're looking at. Deep-seated failures are not a concern at this site. It is a pretty stable backfill, so we're just going to click the no and OK and skip it. So, so we've gotten through everything. So we're just going to click to get back on that main screen. And here you can see the model in place, and you're ready to run the analysis. So you first option, just click that tab. The second option is to run. Let you manually place each geogrid layer. I would highly recommend not that. I would run this one, which is a run geob, optimizing elevations of each geo, the reinforcement layer, and that was the 2-foot that we put into the original option, and we selected that in that previous tab. So that's pretty time consuming if you go into and do that. So stay with the run geob MSE. Once again, just click OK here. And here you are into your program. Once again, we can look at the layout and the tabulated results. So we'll look at the layout. Here you're going to see it ran the analysis, 15-foot high wall, a 3-cell wall panel here. It shows the geogrid lengths of 12.67, shows the surcharge loadings. But if you look here, some reinforcement layers are overstressed, specify stronger and or more reinforcement. So that is an error message. That's what I was talking about before. So you're always looking for that note in the upper right-hand corner. So with that, we have to go back and look at using different geogrid layers. So we'll go back a tab. Here you can see here you can see how we were looking at the failures on the different types, where we can see that is actually overstressed. See, we get an actual factor of safety for tieback of 1.18. So that's what's giving us that error message. So we're going to go back and we're going to modify that input data. You're going to look at the GeoHub Design Data tab. You're going to click on that. That's going to bring you back to that tab where you can actually go ahead and select a different type of GeoGrid here. So you'll want to click the next one and then hit OK. Once again, we're going to run it. Going to look at the view layout configuration. And here you go. Same 15-foot high wall, gives you your tiebacks and gives you your surcharge. But as you can see here, there's no error message. So that means the wall is adequate. You can look at the different layers. You can click on all the different layers. See, we're always shooting at that factor of safety at 1.3. It'll give you the mode of failure, whether it's a compound or a tieback. You can see the actual factors of safety and showing that you use a different mirror grid. You can see how now all of our failure planes are within the GeoGrid tieback area. You can check it for all the different types and the different layers. Here you can see that this one shows, since you selected multiple layers, it does show here that in this level 3, it goes back to, it defaults back to that 2XT. You know, the price of the GeoGrids are pretty, not that significant. So if you're looking at different types of GeoGrid over a small, you know, reinforced wall, I would just go with, say, for instance, this one. Since 2XT didn't work for the entire wall, 3XT did. I would look at, you know, just going with the 3XT wall to make sure that it's hard in the field. Sometimes with the contractors, they may get confused over where to put the 2XT versus 3XT. So we can work with you and our distributors to show you the price difference in those two grids. But most of the time, especially on these smaller walls, it pretty is insignificant. So we can go back and look at the tabulated results. Here you go. We're going to check on our tiebacks. Here you can see it's going to show all the different layers. It's going to show you that the factor of safety is over that 1.3. It's going to give you all the different layers. Here you can see that it'll change the different grids, 2XT and 3XT. As I just mentioned, I would try to stick with one. If it's not a very big wall, it's going to save you time. And like I said, the costs will easily be made up during construction. Here you can see all the factors of safety. Look at the tieback and compound results. Here's going to give you the mode of failure, you know, whether it's a compound or a tieback. It's going to give you all your different GeoGrids, the types, the lengths. We can look at the direct sliding and deep seated results. Here you can see, you know, when we're looking at the status of all of them, whether it's a direct sliding or tieback or compound failure, we get an OK here, which is what we're actually shooting for. And here you can see we're just done with our wall. Now, once again, we can print it the same as a gravity wall. You're going to get that same output here with a really nice PDF. It's going to give you the type of GeoHub you selected. It's going to give you all of the summary of all your different types, your height, your tiebacks, your surcharge loadings, you know, distance to your surcharge. Once again, all your soils data, all your seismic data, if it's applicable, all your factors of safety. And once again, for the reinforced wall, it's going to have this table, which is going to give you a summary of your tieback and your compound results. So here it's going to show you all your different types of factors of safety, your status, the GeoGrid used to achieve that factor of safety. And here's what I was talking about, is we need that 3XT only really for this one layer. So you're not going to buy one roll of GeoGrid and just for that one layer. So once again, I would highly recommend just going with the 3XT. You know, like I said, we can work with our distributors in that area and show you the difference of cost. But like I said, it'll easily be made up in the in constructability on site. So once again, your mode of failure, the GeoGrid used. And then once again, another tab will show you your deep-seated failures. Here you can see the tieback results. Here's the required tieback in pounds per foot. And once again, this will also print out a metric. So if you're looking to use a metric, this is also available in your metric from your front tab. So it gives you your results, your direct sliding and your tiebacks. Here once again, it'll give you the number of panels of 30V, the number of lists. Once again, it's all a 3-cell GeoWeb panel. So the wall is complete. Here, this one was installed a couple of years ago. Vegetation, especially in northern Wisconsin. After I took these pictures, basically about 3-4 months after that wall, so you can see, the vegetation is coming in slowly. Been up there a while, like a year back or so. It's all vegetated, looks very good wall. One last thing that I want to really clear on walls and reinforced slopes is there is some limitations with the software. So I've touched briefly as we've gone along. The first is, there are a couple different soil conditions that we can look at. That's your infill soil, your retained soil, and your foundation soil. So if you're looking at different types, you may want to look into a more detailed software such as RESA. The second is that, gravity walls, limited 8 feet. So once again, you can always go with a reinforced wall. Another thing is water. This program does not look at water. So water is and always will be the biggest thing for any type of gravity reinforced or reinforced slope. It is a leading cause of all the failures. I would say almost every failure that I'm aware of is caused to poor pressure buildup and bad issues with walls. So by nature, GeoWeb allows for movement through the wall because our perforations here and our solid face, it's going to allow a lot of water to flow freely. But once again, like I said, we always want to make sure that we use some type of a drainage pipe. Usually it's going to be either a perforated pipe wrapped with a non-woven geotextile, or a perforated pipe wrapped with a non-woven geotextile inside of a trench. But like I said, very critical with any type of wall is to make sure that you properly look at the drainage and make sure you account for it in your design. You're going to actually daylight all your drainage pipes through the front face of that wall. The spacing, whether it's 20 feet, 30 feet, 50 feet, is pretty much based on your site conditions and how much you want to make sure that you don't have a lot of water getting into that drainage system. So you want to make sure that you design it with a minimum slope to make sure that water flows freely. And another key item here is to make sure that penetration doesn't stop at the front face of that wall. You want to make sure it extends out past the wall a couple feet. So if there's going to be some erosion here, you account for that, whether with splash blocks, which I've seen a lot of engineers use, riprap with non-woven geotextiles. But yeah, just don't make sure that you end it at the wall and then it starts to scour and undermines the front fascia of that wall. So made it through. I know there was a lot of different screens popping up. So I hope you were able to follow along. Like I said, it is a very, very easy software to use. GeoWeb panels have been used for walls for, basically 40 years. We do have the good thing about the walls, besides being very flexible in that differential settlement, we can fill that front fascia with either topsoil and vegetate it. If it's a more durable surface you're looking for, aggregate and concrete for more of a hard armor surface, maybe if it's by the side of a creek or some of those hurricane channels that I showed you before. We have lots of research at the Colorado State Hydraulics Lab for all of these different infills and what type of velocity and shear stresses that it can work with. So like I said, if you're interested on that, please let me know and I can get you those research summaries. This MSE software, 100% free. Like I said, I have thousands and thousands of licenses out there to different engineers all around the world that have used this software. Like I said, it is an annual renewal every December. I have some engineers that used it 3 years ago and didn't have to design a wall. They haven't redone their software. They reach out to me like this year and say, Brian, I'm trying to doing a wall. I'll issue them another update so that they can use the same software. Our evaluations, and we'll work with you to review your walls. If you do an MSE wall design, it is going to be a complete solution. We're going to include that Atra wall key that's going to provide that permanent connection, something that staples and zip ties cannot do. We're going to work with you whether it needs a GeoGrid for tiebacks for reinforced walls. We're going to give you the strength, we're going to give you the type, and we can work with different manufacturers, especially if you have one in your area that you like to work with. So here you can see just from our website, we have a really good website here. This is if you're looking for a pre-project evaluation, you just click on this tab and it hops into here and you can fill out an RFP. And it's going to come to us. You can attach CAD drawings, you can attach soils reports, any kind of information that we can look at for that wall. It's going to come to me and we'll do a free evaluation for you. Typically takes a day or two to get back to you. I said with all the different items such as a written summary, calculations, cross sections, specifications on the GeoWeb, the GeoGrid, anything that we're using in that evaluation. Once again, here you can go to our website and just request a license from the GeoWeb MSE. That is right from that design tab here on our website at prestogeo.com. We have a great website where it has all these different tabs, products, applications, that design tab, installation, methods. We have this learning tab here. We have hundreds of pre-recorded webinars that you can go in and actually sign up and get PDH credits, and it'll keep track of it for you. We also have a YouTube video here with hundreds and hundreds of videos that we use a lot on a daily basis with contractors, engineers for, say, installation purposes. We do have a pretty easy and fast way to do our PDH certs. So with our webinar dashboard, you can view a library of those certifications and all the on-demand webinars that you take. That dashboard will keep track of all those, and along with all the PDHs that you learn, you have completed. The live webinars are managed separately, from the on-demand webinar dashboard, so you won't find your certificate in there today. So you should receive an email from GoToWebinar in the next couple hours, where you can download a link to get your PDH cert. In a couple of days, if you don't get it, you'll receive a separate email from us at Presto with information about accessing the on-demand webinar dashboard and other helpful resources. If you don't receive either of those emails, take a look at your spam folder or reach out to me. So with that, I really do appreciate your time. Here's my contact information. Here's my phone number. Here is my email address. If anything happens to come up over as you're looking through, let us know and we can work with you on that. I do have a little bit of time where I can answer some of the questions here. Let's see. Oops. Can we print a certificate? Yeah, that's going to be, how do I download the slides? If you're looking at maybe a copy of this presentation, it will be on in your PDH credit. Couple persons missed a few minutes. Like I said, the C used for landscape architects. There is no quiz at the end here. Let's see here. Closed captions available. Unfortunately, no. Sorry about that. Like I said, people keep asking about the PowerPoint. It will be on our dashboard and you can download it. Let's see. Yes, the walls, we can, like I said, there's multiple panels, panel diameters and different types. Like I said, the 6 and 8 inch height. Like I said, if you're looking at the different types of GeoWeb that you can use for the walls, like I said, just reach out to me. We can help you on that. So with that, I think we're pretty much done. There's a lot of questions regarding how to use it. And like I said, I know I did talk a little fast and didn't really talk about construction costs that much, but our walls are going to be a lot less than any type of rigid wall. Since the panels are so lightweight, any type of landscape contractor can actually work on them. So let's see a couple other ones. Let's see, download the slides again. GeoWeb MSE, how to get it. Yeah, like I said, just reach out to me via email or go on our website. Just like I said, with that, I'm not gonna be able to get to all of them. I apologize. So if you want to just reach out to me and I can help you with that. So with that, I thank you for joining us today. And so if you have any questions, please reach out to me via phone or via email. So with that, thank you very much. And thanks for joining.